Hello everyone. We have already discussed electromagnetic waves. Today we are going to discuss electromagnetic spectrum. Actually, different sets of electromagnetic waves having specific frequency and wavelength range and differing from each other by means of different types of properties. When they are taken together, we consider it as electromagnetic spectrum. Electromagnetic spectrum simply means different sets of electromagnetic waves having different range of frequencies and wavelength. So we are going to discuss all of them in details. Let me read out the statement for electromagnetic spectrum first. The orderly distribution of electromagnetic waves in accordance with their wavelength or frequency into distinct groups having widely differing properties is called electromagnetic spectrum. That means all the electromagnetic waves, they are separated from each other in a group or a range of wavelength or frequency, and all these ranges which are forming a particular group, they have a specific property which differs from the other. So that separation or that segregation of the properties according to their wavelength or frequency range is known as electromagnetic spectrum. You need to understand that when we consider electromagnetic spectrum, we need to understand here a very important thing, that in electromagnetic spectrum, let me show you how we can represent the electromagnetic spectrum. Suppose we take a line here which parts will show different types of electromagnetic wave. Like if we start from the beginning, initially we have gamma rays having maximum frequency, then comes the X-rays where the frequency decreases, then comes the ultraviolet rays, then comes the visible light, Now you need to understand here, when we consider visible light, it has 7 different colors: V, I, B, G, Y, O, R. Then we have infrared rays, then we have microwave, and finally we have radio waves. Now see, all these are electromagnetic wave and all of them have the same velocity, which is given by c, velocity in air or vacuum. All the electromagnetic waves have the same velocity, which is given by nu lambda, frequency into the wavelength, and whose value is a constant quantity, 3 into 10 raised to the power 8 meter per second approximately. So here you see, when we move from the left hand side to the right hand side, suppose we are moving in this direction from the left to the right hand side, what we see is the frequency increases. And wavelength decreases. Because just the reverse I am saying, frequency decreases here, frequency decreases, but the wavelength increases. You should understand here that when frequency decreases, wavelength must increase so that their product always remains the same, which is given by C, which is a constant quantity in air or vacuum, 3 into 10 raised to the power 8 meter per second approximately. So as we move from left to right, the frequency decreases. So you can see here the maximum frequency is of gamma rays and the minimum frequency is that of the radio waves. You should understand one more thing here, that energy of an electromagnetic wave is given by frequency, h nu, Planck's constant into frequency, or we can also write it as hc by lambda, because nu is equal to c by lambda. So you can see here, if the frequency increases, energy increases, but when the wavelength increases, energy decreases. So as we move from left to right, the frequency decreases, that means energy decreases. Or we can say, since the wavelength increases, energy will decrease as we move from left to right. So radio waves are having the maximum wavelength but the minimum frequency. Then comes the microwave, then infrared. So what we will do here is this set of all the electromagnetic waves having different range of frequencies and wavelength, that we will discuss separately, and we will see what are their frequency range and wavelength range and what are their uses. So see to it very carefully and see if there is any doubt, then you can post me the doubt after the video. We start with extreme right side, where the electromagnetic wave was radio wave, which is having maximum wavelength but minimum frequency, so very less energetic here. So wavelength range you can see 600 meter to 0.1 meter. It's quite a high range. Wavelength is the largest, but frequency it's minimum, very less, 500 kilohertz to 1000 megahertz. It's considered to be very less frequency. And most important uses, all the radio, TV communication, in mobile communication, these are always used. Then in radio astronomy, radio waves are sent to the atmosphere and it strikes the astronomical objects, comes back, and that is studied. So radio waves are also used there. Next is microwave. In microwave, the wavelength range decreases as compared to radio wave, but the frequency will increase. So the radio wave, the microwave here having a wavelength range from 0.3 meter to 10 raised to the power minus 3 meter, and frequency range is 10 raised to the power 9 hertz to 10 raised to the power 12 hertz. Now microwave, the important uses are, it is used in radar system, then it is used in radar, if you remember, it is radio detection and ranging, so there it is used. It is used in long distance communication, for example in geostationary satellite microwaves are used, and even in microwave ovens. You must have seen in your home if you use the microwave oven, so these are the microwaves which are responsible to heat up the food material which is kept inside the microwave oven. Then next type of electromagnetic wave is infrared rays. These are also called heat or thermal waves, because these electromagnetic waves have a property of producing heat where it falls or where it moves. Electromagnetic wave, the wavelength range is from 5 into 10 raised to the power minus 3 meter to 10 raised to the power minus 6 meter, and the frequency range is 10 raised to the power 11 hertz to 5 into 10 raised to the power 14 hertz. Now let me tell you one thing here. See, for microwave, the frequency range, it is written here 10 raised to the power 9 hertz to 10 raised to the power 12 hertz. But here the frequency range has to increase. But it starts from 10 raised to the power 11 hertz to 10 raised to the power 14 hertz range. So here you can see in the frequency 10 raised to the power 12 comes here in the infrared range also, as well as in microwave range. So you need to understand that there is not a proper bifurcation of the frequency or the wavelength range for different waves. They can overlap each other. So you need to understand that you cannot have a fixed value at the edges, like when the range, the limiting values may match with each other. So that you need to understand. So you need to remember the powers of 10, which is responsible for setting up the frequency range or the wavelength range. Now, some of the uses of infrared waves. So you must have seen the remote controls uses infrared, whether it is a TV remote or any other kind of remote, infrared rays are used. Then greenhouse effect, like infrared rays are responsible for producing the heating effect in a greenhouse effect. Then infrared lamps are used for reducing muscular pains, reading secret writings, or it is also used in molecular structure studies. Okay. Now next comes the visible range. Now visible light having 7 colors VI, BG, YOR, starting from violet, indigo, blue, green, yellow, orange and red. So all these 7 colors, the wavelength range is from 8 into 10 raised to the power minus 7 meter to 4 into 10 raised to the power minus. The frequency range, as you can see, 10 raised to the power 14 hertz to 10 raised to the power 14 hertz, but 4 into 10 raised to the power 14, and here it is 7 into 10 raised to the power 14. So there is a very little difference in the frequency range. Obviously, you know, maximum uses of light for any kind of visual, we can see anything because of visible light only. Some chemical reactions are also responsible, which is actually take place because of the visible light. Then comes the ultraviolet light. Frequency range, as you can see here, it's given 10 raised to the power 16 to 10 raised to the power 17. Uses, important uses: fruit preservation, study of invisible writing, forged documents, then fingerprints, all these things. Then molecular structure study is also done by the ultraviolet light. Okay. Next is X-ray, where the wavelength range decreases and the frequency range also increases. Let me tell you the wavelength range here. I have not mentioned it earlier. The wavelength range is in the range of 10 raised to the power minus 9 meter to 10 raised to the power minus 3 or minus 12, sorry, 10 raised to the power minus 12 meter. And the frequency range is 10 raised to the power 16 to 10 raised to the power 19 hertz. So you can see that there is a little bit of overlapping between X-rays and ultraviolet rays. But X-ray, there are a lot of uses of these X-rays. It cannot penetrate bone, so it is used for the study of the structure of your bone. Then for crystal structure also this is used, for detecting faults, cracks, then detecting explosives, then diamond, gold, etc. by detectives they are used. And finally the gamma rays, most energetic rays, having very less wavelength and very high frequency. The maximum frequency rays 10 raised to the power 18 to 10 raised to the power 22 hertz, used in radiotherapy, then manufacture of polyethylene, then initiate nuclear reactions, preserve food for a very long time, and study of structure of atomic nuclei. So I hope this is very clear to you. Any doubt, you can post me the doubts.